So in this equation, we have the product cosine of x times tangent of x. And if you recall the identities we learned from the trig hexagon, the product identities make hinges. So the product of tangent and cosine, they hinge together here at sine. So we're going to use that product identity to replace cosine times tangent with sine of x. And that's minus 2 cosine squared of x, which equals -1. Okay, our goal is, if possible, to get this entire equation in terms of one trig function. And if we look back at our trig hexagon, this cosine squared x comes from a Pythagorean identity here from this top triangle. Sine squared x plus cosine squared x is equal to 1. So we can replace that cosine squared x with 1 minus sine squared x. And we need the parentheses because that coefficient of -2 belongs to cosine squared x, which is being replaced with a binomial, 1 minus sine squared x. So we'll need to distribute that -2 over the parentheses to get -2 and then plus 2 sine squared x, and that's still equal to -1. Now we've got a sine squared x term and a sine of x term. That's a quadratic term and a linear term. So we're going to do a quadratic process for solving this equation, which means it first needs to be set equal to 0. So let's have our leading term be the quadratic term, 2 sine squared x, then our linear term plus sine x, followed by our constant, which is a -2, and since we want it equal to 0, we're going to add 1 from the other side. So -2 plus 1 then is a -1, and now it's equal to 0 and in quadratic form. So we can go ahead and factor next, and this will be 2 sine of x with a 1, sine of x with a 1, and we need bigger on the outside so that we have that positive sine x in the middle. So now we're completely factored. We can use the 0 product property next to set each factor equal to 0 and solve for x. So in this case, sine of x is equal to 1/2, and we're going to use the inverse arcsine to get x by itself. So this arcsine of 1/2 is asking which angles on the unit circle over the interval 0 to 2 pi inclusive have a y-coordinate of 1/2, and that occurs at pi over 6 as our principal value in quadrant 1. Sine is also positive. All students take calculus. Sine is positive in quadrant 1, but also positive in quadrant 2. And so our second solution is 5 pi over 6 in quadrant 2. So there's 2 answers. Then if sine of x plus 1 is equal to 0, that means that x is equal to the arcsine of -1, and that occurs at 3 pi over 2. That's a quadrantal angle. And those would be our 3 solutions: pi over 6, 5 pi over 6, and 3 pi over 2. We're going to use the graphing calculator to check those answers. So let's see here. We've got to check that we're in radian mode, which we are. Then we're going to store pi over 6 in the calculator as the x and type that in our original equation: cosine x tangent of x minus 2 cosine x and squared, and then the equals from the test menu, and we want that to equal -1. And we get back a 1, so we see that that checks. Okay, next we're going to check 5 pi over 6 by storing that as the new x. Then we can arrow up to that equation, press enter. That'll copy it down so we don't need to retype it, and press enter again. We get a 1, and so that answer checks. And our last answer to check was 3 pi over 2, our quadrantal angle. So we're going to store 3 pi over 2 as the new x. Arrow up to that equation again. Press enter. Whoop, and we get a domain error. And that tells us that 3 pi over 2 is not going to check. It's outside of the domain of our original equation. And so we're going to cross that solution off and write extraneous. Okay, so we know that pi over 6 worked and 5 pi over 6 worked. Those two answers check, but the 3 pi over 2 answer we discard as extraneous.